If this is going to be test 4 review, I might suggest turning off the recording, trying to do as many of these problems as you can on your own, self-assessing, and then coming back and checking the key. All right, for test 4, we're going to write the augmented matrices for each of the following systems of linear equations. So an augmented matrice. We're going to grab the coefficients of all the variables, filling in any zeros if we have any missing variables. And then we're also going to grab the answers, the numbers that are to the right of the equal sign. I might look down the column here. So it looks like 7, 5, 1. Okay, and coefficients for the y's are 1, -3, -8. And the z coefficients are 3, -1, and -3. And then finally the answers, 5, 7, -6. Sometimes you'll see a little vertical bar here to separate the coefficients from the answers. It's not necessary. Number 2, another augmented matrix. In equation 1, we have all 3 variables, x, y, and z, but you can see in the later 2 equations that we're missing some variables. So we want to be mindful of filling in zeros. So it looks like I'm going to have 1, 0, 0. And for the y's, -1, 1, and then a 0. And then the z's. And then finally the answers. I happen to go down in column format, but of course you can go across in row format. Number 3, use the matrix to perform each of the following row operations. So in part A, it tells us to multiply row 1 by 1/4. So row 2 and 3 will stay unchanged. So I would write row 2 and 3 down first. And then multiplying every element in the first row by 1/4, which is the same as dividing by 4. So 4 divided by 4 is 1, 8 divided by 4 is 2, etc. All right, for part B, we're still using this matrix right here. This tells us that we're going to take row 2 and multiply every element by -4, and then add that value to what's in row 3. So the row that's going to change is row 3. So I'm first going to re-record row 1 and 2 unchanged. All right, to generate row 3, I'm going to go over here to this matrix and I'm going to multiply row 2 by -4. So that would be -12 plus 2 is -10. Going back to this matrix, multiplying -3 by -4 is +12 plus 0 is 12, etc. Problem 4, given the following matrix, this one, identify the order. Well, the order is how many rows and columns. Rows comes first, so we have 2 rows and 3 columns. And then we want to identify the element A subscript 3, 1. So let's go to the third row, first column. Problem is we don't have a third row. We only have 2 rows. So for this one, we would just say doesn't exist, undefined. You could put a circle with a line through it, and that means empty set. All right, what element is in the first row, third column? So first row, third column, that would be 4. Find the values for the variables so that the following matrices are equal. In order for these two matrices to be equal, corresponding elements have to be equal. Meaning x has to equal 2 because they're in the same position in each of these two matrices. So x equals 2. Okay, then I'm going to have 2y equals 2. But they want me to find the values for the variables, so we're going to have a little bit of work to do here. So divide both sides by 2. So y has to be 1. All right, bottom left, Z is equal to 19. And then those are the only variables I need to find because the two 17s are equivalent, both being in the same position. All right, 6 and 7 ask us to do the same thing, so I won't do both. I think I'm just going to do problem 7. It seems to be the more involved one. 7 says find the following matrices where matrix A is defined here and matrix B is defined here. In A, they want us to add A and B. We can add two matrices as long as we have the same order, and both of these have the same order. They're both 3 by 2, 3 rows, 2 columns. So here I'm just going to add corresponding elements populating the answer matrix. So -2 plus -6, -2 plus -1, etc. Okay, in part B, they want me to subtract. I'm going to go back and erase this. So let's subtract corresponding elements. So -2 minus -6, -2 minus -1, 4 minus -5, etc. For part C, they want us to take and triple. This is a scalar multiplier. They want us to triple every element in matrix A only. So multiply every element by 3. So for part D, we're going to multiply every element in matrix A by -8, and then subtract every element in matrix B once we multiply by 2. So I'm going to actually do a little more work here. I'm going to make it kind of skinny so I have room, but -8 times A. So let's go back and multiply every element in matrix A by -8 and record that here. It's -32. No, it's kind of crowded. +48 and then +72. So this is -8A, and then I'm going to have minus, and then here I'm going to record 2B. So let me go back and double everything. I'm going to have this minus here. That takes care of that minus. So let's just multiply every element here by 2, and then we'll subtract. Okay, and then we can just use our calculator to help us do this subtraction. So this is 2B. The last thing is we just subtract. So 16 minus -12. This 16 minus -2. -32 minus -10. And -48 minus -12, etc. See what else we have. Okay, in problem 8, we're given two matrices and we're asked to find, if possible, the following, the products. To remind ourselves about what criteria is needed for us to multiply. Okay, we need to look at matrix A, find its order, which is 2 by 2. Look at matrix B, find its order, which is also 2 by 2. And since the number of columns match the number of rows, we can multiply, and the answer matrix will be a 2 by 2. So I'm going to go ahead and build a 2 by 2 matrix here. And what we did is we actually filled in the little blanks here. And we labeled, this blank is in position row 1, column 1, row 1, column 2, etc. Because what this did for us, it reminded us that when we go to multiply for this blank right here, the answer comes from multiplying row 1 in the first matrix times column 1 in the second matrix. And we have two values in here, two elements, and we have two elements in here, so we match them up and multiply and then add. So these two numbers multiplied is 45 plus this product is 4. So it'll be 49. This right here, this label reminds us that we're going to take row 1, but now we're going to multiply it by the elements in column 2 in this matrix. So negative 72 plus negative 1. And then likewise, row 2 gets matched with column 1. So now row 2 gets matched with column 1. Negative 30 plus negative 20 is negative 50. And then row 2, column 2. 48 plus 5 is 53. Okay, for part B, we are going to be able to multiply matrix B times matrix A. And just for myself to have it in the right order, I'm going to put negative 5 up, or matrix B up front. And again, we're going to have a 2 by 2. Make it kind of big here. So row 1, column 1. 45 plus 48. Row 1, column 2. 5 plus 40 is 45. Now drop down to row 2, matching it with column 1. So 36 plus 6 is 42. And then lastly, 4 plus 5 is 9. Not the same answer that we got here, and most times it's not. It's probably rare that you're going to get the same answer if you multiply A times B and then B times A. So problem 9. Given matrix A, which is 1 row by 4 columns, can I multiply that by matrix B, which is 4 rows, 1 column? Yep, I can, because the columns match the rows here, and my answer matrix is just going to be a 1 by 1. So I can multiply A times B, and my answer is just going to be 1 row, 1 column, so I'm just going to have one answer here. Because we're going to take that row and multiply it by that column. So we're going to do 4 multiplications when we pair these numbers up, and we're going to add all these sums. So 25 plus 36 plus 49 plus 64. You did all that on the calculator, you get 174. All right, is it possible to multiply B times A? Well, let's see, B's matrix has order 4 by 1, and A's matrix is 1 by 4. Columns match rows, so yes, my answer is going to be a 4 by 4. So I'm going to actually put the B matrix up front just to have the better visual right here for me. Okay, so this is B and this is A. My answer is going to be a 4 by 4. Ooh. 4 rows, 4 columns. All right, so this is row 1, column 1. So we multiply 5 times 5. There's only one element in each row and column, so that's really not bad. So 5 times 5, 25 gets placed here. You can label these blanks, but it's kind of crowded. If you have more paper, if you need to do so, that's great. Multiply 5 times 6, that's 30. Then 5 times the 7, and then 5 times the 8. Now let's drop down to the second row, which is 6, and multiply it by each of these numbers. So 6 times 5, 6 times 6, 6 times 7, and then 6 times 8. We'll drop down and multiply 7 times each of these numbers, populating that row, and then we'll drop down and multiply 8 times each of these numbers to populate that row. Kind of tedious, but not altogether difficult. All right, let's look at 10. More multiplication. Matrix A, matrix B, find if possible A times B and B times A. Well, let's see, A's dimension, or order, 3 rows, 2 columns, and here we have 2 rows, 3 columns. So I am going to be able to multiply A times B, and I'm going to end up with a 3 by 3. 3 rows and 3 columns. Again, you can label each of these blanks if you want. Otherwise, we're going to take row 1, multiply it by column 1. -6 plus 4, -2. 10 plus 5 is 15. That's going to go here. And then multiply by the last column. 8 plus 1 is 9. Okay, let's drop down to row 2 and multiply by each of these 3 columns. So 15 plus 12. -25 plus 15. -10. -20 plus 3. And the last row. -3 plus -12. 5 plus -15 is -10. And 4 plus -3 is 1. All right, let's see if we can multiply B times A. The order of B is 2 by 3. That comes first, and then A's order is 3 by 2. So yes, we can multiply. Our answer matrix is going to be a 2 by 2. Before I build that, though, I'm going to put the B matrix up front. And then I'm building a 2 by 2 answer matrix. 2 rows, 2 columns. So row 1 times column 1, there's 3 elements in each now. So -6 plus -25 plus 4. I believe that's -27. Now I'm going to multiply row 1 times column 2, so that's 3 plus -15 plus 12. I believe that's 0. And then we'll drop down to row 2. -8 plus 25, 17 plus -1 is 16. And this is all just done on the calculator. 4 plus 15 is 19, plus -3 should be a 16. Okay. And then I'm going to leave number 11. That'll be found on the key. Okay. I believe you can do both those multiplications. I believe you can do both A times B and B times A. Yes, you can. Okay, let's move down to evaluate the determinants. Okay, these are determinants because we don't have these little brackets on this array of numbers. We've got these absolute value symbols here. But determinants for a 2 by 2, this square matrix, down arrow, the product, 6, always minus the product of the up arrow, which is -20. So that determinant is 26. Now the 3 by 3 determinant is a little bit more involved. This is expansion by minors. This is where we decided if we look into our matrix, if we see any zeros, we want to choose a row or column that has a 0 in that row or column. So we can certainly choose row 2 or we can choose column 2, doesn't matter. I'll just go ahead and choose row 2. So I'm just going to lightly circle row 2. That's my choice. And don't forget the sign pattern chart. The sign pattern chart starts positive, negative, positive. Then it's negative, positive, and then negative above here. What we did is we went to the first element in our circled row and we said, oh, okay, this is 6, but there's a negative in front. And then we built the 2 by 2 determinant by crossing off this row and this column, leaving -1, -3, and 3, 2. Then we move to the second factor, second element in that row, which is a factor, plus 0. You could build this or not. I'm not even going to build this determinant, this minor. Then I'm going to move over here to this other element, which becomes our last factor, so it's minus -5. And then I'm going to build the minor by crossing off this row and this column. So at least we only have two 2 by 2 determinants to find. So this is -6. I'll just go ahead and put that in parentheses. I did a bracket here. Down arrow product minus the up arrow product. Of course, this is going to be 0 here. Now, minus negative is going to be your +5. You can use parentheses or not. Down arrow product, 15 minus -4. So reaching inside here, simplifying, we get 7. And then parentheses or not, your choice. And then this is 19. So it looks like it's going to be -42 plus 95. It looks like -42 plus 95. 53. Right? All right. All right, continuing our review, it looks like we're going to use Cramer's rule to solve the following system. Cramer's rule means use determinants like we just did. Okay. Solving a system of linear equations with 2 variables isn't bad. I think the first thing we did was we decided we wanted to solve for x, and x is going to be equal to d subscript x over d, and y is going to be dy over d. So we need 3 determinants here to find the values of x and y. Gosh, it'd be so easy just to draw a line here and add down and solve by using the elimination method. But we will do this method. All right, so the D matrix, or determinant, excuse me, coefficients, 7, 4, 4, -4. We need D subscript x. Replace the x column with the answers, 47 and 8, but leave the y column, and then dy. Keep the x coefficients, but replace the y coefficients with the answers. Not too bad. -28 minus 16. That looks to be -44. Ooh, 47 times -4. 28, 188, -188. Minus 32. And that's going to be -220. And that's 56 minus 4 times 47. Oh, that's that 188 again. And that's -132. And I'm going to leave this one for you to solve, and it'll be on the key. I've crowded myself here, so I'm going to take this and move it down here. So x is equal to -220 divided by -44. And that is a nice number. I believe that's 5. And then likewise, y is equal to d sub y, -132 over -44. And that is a nice number, 3. And we record our answer in ordered pair form. All right, to solve 16, we're going to use Cramer's rule as well. I see there's 3 variables, x, y, and z. So we're going to need actually 4 determinants, the d, the dx, the dy, and the dz. But thank gosh there's a lot of z, or at least there's 1 0 in here we can work with. I think for this one I'm just going to set it up and then just kind of abandon there, since we just did a 3 by 3 determinant. So let me just get the setup here. So when evaluating this 3 by 3 determinant, I'd either choose the last row or the last column to do all that work to get the value of D. And that 0 is still here. So again, when you're going to find this one, I'd either use the third row or the third column. And I'm actually just going to do the setup over here. Won't do any more of the work with these though. For the D sub y, we're going to replace the y column with the answers, leaving the x and the z. And when we go to find the value of this last determinant, unfortunately that 0 has been knocked out with the answers. So we'll have a little more work to do on this. Okay, and so on the key, it has all that worked out. All right, that concludes, I think, what's in chapter 6. So what we have left is a little bit from chapter 8, and I think I'll do that in the next video.